So we saw this. We saw this. We saw that x squared minus 16 I can factor because I know that this is a binomial that can be written as how? Difference of two squares, meaning that I can write this as the difference of something squared minus something squared. And so what goes inside this parentheses? X. What goes inside this one? 4. So if I can fill in the parentheses, then that is the difference of two squares, this right here. So that means then I can factor it as how? X minus 4, x plus 4. Okay? But what if I had this? X cubed minus 8. X cubed minus 8. All right, so what's the GCF? 1. How many terms do you see? 2. So at this point, all you know is that, well, if I have 2 terms and the GCF is 1 and there's a subtraction in the middle, then everything I've had so far was, in this lesson, was the difference of 2 squares, right? But this is not the difference of 2 squares. First of all, 8 is not a perfect square. So this is not the difference of 2 squares. And secondly, my exponent is not squared. It's not 2. It's 3. So now we're going to see something now. What I want you to do is this. We're gonna multiply this out. X minus 2 times x squared plus 2x plus 4. Let's go ahead and multiply this out, see what we get. X minus 2 times x squared plus 2x plus 4. Now, you can't use a FOIL method here to multiply this out. When can you use a FOIL method? When you're multiplying 2 binomials. One's a binomial, the other one is a trinomial. So you may remember in Math 98 last semester that when you have a binomial times a trinomial, you use the distributive property, not the FOIL method, although the FOIL is a type of distributive property. So the way to do this is this. You're going to take the first term here, and you can multiply by this trinomial. So write this down. You're going to say x times x squared plus 2x plus 4. So you're distributing, basically. You're saying x times this trinomial. Then you're going to say minus 2 times this trinomial. Minus 2 times x squared plus 2x plus 4. Okay? So that's what you did last semester when you had a binomial times a trinomial. You took each term, multiplied by that second parentheses. What was inside the second parentheses? Now distribute. What's x times x squared? X cubed. Oh, and at some point you're going to notice, see, there's an x cubed, right? See right here? Okay. What's x times 2x? 2x squared. Good. What's x times, that's a 4. Okay, 4x, good. Then let's distribute the negative 2. What's the negative 2 times x squared? Good. What's negative 2 times 2x? All right. And what's negative 2 times positive 4? Negative 8. Let's combine like terms. When I combine like terms, there's a positive 2x squared and there's also a negative 2x squared. They cancel out. That's 0. There's a positive 4x and a what? Negative 4x. They cancel out. That's 0. What's left? X cubed minus 8. Is that what this is? Yeah. So it turns out that I can factor this. The factors of this are these. Because remember, factoring is where you write it as a product of factors. So this right here I can factor as x minus 2 times x squared plus 2x plus 4. Now you may say, well, how'd you get that? We're about to talk about that. But I want you to notice this, that that when I multiplied this out, when I multiplied those two factors, what's the first factor? X minus 2. What's the second factor? X squared plus 2x plus 4. When I multiplied those out, I ended up with a binomial, which was this one. So if you're asked to factor this would be your answer. Now the question is, how did we get that? All right, well, here's the idea. In the previous lesson, we talked about the difference of two squares. And we talked about perfect squares. So we talked about the fact that perfect squares are, what's the first one? 1. Next? 4. 9. 16, and so on, right? Because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. But there's also something called perfect cubes. Perfect cubes. All right, so let's look at what our perfect cubes are. 1 cubed is what? 1. 2 cubed is what? 8. So my perfect cube, my smallest perfect cube is 1. What's the next perfect cube? 8. What's the next perfect cube? 12 is not a perfect cube. 27, because 3 times 3 times 3 is 27. Now use your calculator for the next one if you need to. What's the next perfect cube? Use your calculator. 4 cubed. 4 times 4 times 4. 64. Thank you. Took you a while to punch in 4 times 4 times 4 in a calculator. The next one would be what? What would I write? 5 cubed. What's 5 times 5 times 5? 125. So those are your perfect cubes. And so if you look at this, now remember when I did this one right here, I asked myself, is this the difference of two squares? And if it was the difference of two squares, then that means I can fill in these parentheses, right? Okay? All right, well, let's ask ourselves this here now. Is this the difference of two what? Cubes. Difference of two cubes now. And it is. Now, here's how you're going to test it. So far, you know, we've talked about this. The difference of two squares, the sum of two squares. Now we're focusing on the difference of two cubes. Okay, now listen carefully. First of all, do y'all agree that this is the difference of two cubes? Because I can write this as something cubed minus something cubed. What times itself 3 times is x cubed? X. What times itself 3 times is 8? 2. So that's the difference of two cubes. Now remember when we talked about that formula earlier about the difference of two squares, f squared minus l squared, when we looked at this, it was f minus l times what? F plus l. Now what we want to do is look at this. Well, what is it for f cubed minus l cubed? That's what we want to look at. How do I factor the difference of two cubes? All right, well, look at this. I want you to compare. Remember, that's the answer right here, right? Okay, so you see my first factor is that binomial, x minus 2. Well, isn't that what you see inside the parentheses? Mm-hmm. So f and l. So do y'all agree that my binomial will be f minus l? X minus 2, x minus 2. F minus L. Okay, now listen carefully. My next factor is a trinomial though, right? So how many terms do I need inside this formula? 3. Notice my first term of the trinomial is all I did was I took the first and I multiplied by itself, because what's x times x? X squared. So basically you're going to say f squared. F squared. Whatever f is, you're going to square it, and that's your first term of that trinomial. Compare the signs now. Look, this is subtraction. This is what? Addition. So if this is F minus L, then this sign needs to be the opposite, so it'll be a plus symbol. And then look at this. See, my middle term is 2x. I can get 2x from this by just multiplying F and L together. What's x times 2? 2x. So it will be plus FL. And then it's always plus. And then look, you see I wanted a 4? See this 4? That's just 2 times itself. So L squared. That's your formula. You don't have to memorize this. I'll give you the formula. So I'll give you this. You just got to know how to use it. So this is a formula. F minus L times what? F squared plus FL plus L squared. All right, so let's see how we're going to use it now. All right, let's factor number 1. Number 1. What if I had y cubed minus 27? Y cubed minus 27. How many terms do you see? 2. What do you always look for regardless of how many terms you see? GCF. What's the GCF? 1, right? GCF is 1. Okay, now, next thing you need to ask yourself, how many terms do you see? 2. What's the sign in the middle? Subtraction. Okay. Is this the difference of 2 squares? No, because 27 is not a perfect square. And then, secondly, my exponent is 3. So then you want to ask yourself, well, is this the difference of 2 cubes? Okay, and it is. Because I can fill in these parentheses. Those are cubes up here. What goes inside the first one? Y. What goes inside the second one? 3. So this is your F, this is your L. So what's my F? Y. What's my L? 3. Now let's talk about the formula. Let's go back to the formula. F cubed minus L cubed. My binomial is F minus L. And my trinomial is whatever F is, I do what to it? Square it. Plus FL plus L squared. All right, so let's plug into the formula. So my answer, what's my binomial? Y minus 3, good. That's always the easy one to deal with. But now remember, when you factor the difference of 2 squares, it's the product of 2 binomials, right? A binomial times a binomial. When you factor the difference of 2 cubes, it's a binomial times a trinomial. And that trinomial, if you're doing it correctly, that trinomial cannot be factored further. So you leave it as a trinomial. All right, so times. This says I take F and I multiply by itself. What's F here?
Y.
What's Y times Y? Y squared. Then I got to say plus. Then I take F and L and I multiply them together. What is F here? Y. What's L? 3. Y times 3. Always put the coefficient first. 3y. Plus, and then this says take L. What's L here? 3. Multiply by itself. 9. So there's your answer. So y minus 3 times y squared plus 3y plus 9. You cannot factor this trinomial, so don't waste your time. It's not factorable. So that's your answer. Okay. Now, if you took the time and you multiplied this out like we did here, you would get y cubed minus 27. You would get that. Now, remember on that worksheet, I asked you when you factored to check your work, because it was easy to do. You could easily do FOIL on that one. Here, you can't do FOIL. You actually have to say y times all of this minus 3 times all of this and do some more work. So on a test, you're not going to have time to check this. You'll have time to check the foiling on the other problems, but you're not going to have time to check this. So just be careful when you do this. Just make sure that what you put inside the parentheses are correct. All right, so let's look at another one. Let's look at this one. Suppose you had this. Number 2, suppose you had 27 plus 8x cubed. 20, oops. It's a sum, right?
Yes.
Okay. Let me go ahead and make it a difference because that's the only thing we've talked about so far. Difference. Okay, so 27 minus 8x cubed. What's your GCF? What's your GCF? 1. How many terms do you see? 2. What sign's in the middle? Subtraction. So is this the difference of two squares? Always ask yourself that. No. Because 27, first of all, 27 is not a perfect square. 8 is not a perfect square. Secondly, this exponent is not a 2. In fact, it's a 3. So then you ask yourself, well, my exponent's at 3, so is this the difference of two cubes? What are you going to say?
Yes.
Yes. It is a good idea with these to actually do this part. Fill in those parentheses. It is helpful to do this here. What goes inside the first parentheses? 3. Because 3 times itself, 3 times is 27. What goes inside the second parentheses?
2.
2x. Because 2x times 2x times 2x
8x.
is 8x squared. 8x cubed, sorry. So here is your F, here is your L. It helps to denote those. And then all you do is just use your formula. So now ask yourself, is this the difference of two cubes? Is this the difference of two cubes? Yes or no? Yes. You filled in the parentheses. So this is the difference of two cubes. So I can factor using this formula now. So remember, when you factor this with two cubes, it's a binomial times a what? Trinomial. My binomial is always the easiest. What's my binomial? 3 minus 2x, F minus L. 3 minus 2x. All right, now be careful with the trinomial. Listen to the thought process. In my trinomial, the first thing I see is F times itself, F squared, F times itself. What does F represent here? 3. 3 times 3 is 9. So remember, F squared means F times F. That's what that means. And in this case, F is 3. So 3 times 3 is 9. So 9 goes here. Plus or minus? Plus. Then the middle term says I take F and L, and I multiply them together. What is F in this case? 3. What's L in this case? 2x. What do I get when I multiply them? 6x. Good. So that's plus what? 6x. And then L squared means L times L, right? What's L in this case? 2x. What's 2x times 2x? 4x squared. Yes. So that's plus 4x squared. So there's your answer. You're done. So it's 3 minus 2x. So your binomial is 3 minus 2x. Your trinomial is 9 plus 6x plus 4x squared. All right. Now, you remember a while ago I had, first of all, when I did this, I had 27 plus 8x cubed? Okay. But is this the difference of two cubes? No, you know it's not the difference of two cubes, for the main reason being what? It's an addition symbol. So then you might say, well, could it be the sum of two cubes? Yes, this is a sum of two cubes. All right, so the sum of two cubes, because when I look at it, I can rewrite this binomial as 3 cubed plus 2x cubed. Now, don't confuse that with the sum of two squares. The sum of two squares cannot be factored, but the sum of two cubes can be factored. Sum of two cubes can be factored. So for example, let's look at that. What if I wanted to factor x cubed plus 8? That's the sum of two cubes. I'm going to tell you what it is. It will be this. X plus 2 times x squared minus 2x plus 4. Okay? X plus 2 times x squared minus 2x plus 4. Let's check it. Can I use a FOIL to check this? No. Because I have a binomial times a trinomial. Whenever you have a binomial times a trinomial, you will multiply this out. You got to say, I'm going to take each term of the binomial and I'm going to multiply by the trinomial. So you're going to say x times what? X squared minus 2x plus 4. Then you're going to say plus 2 times the trinomial. X squared minus 2x plus 4. And then I'll distribute. What's x times x cubed? X squared? X cubed. What's x times a negative 2x? Okay. What's x times 4? What's 2 times x squared? 2x squared. What's 2 times a negative 2x? Okay. And what's 2 times 4? When I combine my like terms, what do you notice about negative 2x squared and a positive 2x squared? They're 0. They have to be 0. What about 4x and a negative 4x? 0. What's left? X cubed plus 8. So the factorization for x cubed plus 8 is this. And so notice when I did the formula for the difference of two cubes, I had this. I had f cubed minus L cubed. And so I know that when I factor f cubed minus L cubed, it's f. Tell me what to put. Tell me what to write. No. What's the binomial? F minus L. What's the trinomial? F squared plus 2, plus f L plus L squared. So that's a formula we were working with a while ago. Now I want to look at the sum of two cubes. And I want you to notice how similar and different they are. So f cubed plus L cubed. My binomial is not x minus 2 is what? X plus 2. So this is going to be f plus L. Then notice that this is x squared, right? So this is going to be what? F squared. Notice that my middle term this time when I dealt with the sum of two cubes, my middle term was negative. So this is going to be what? Minus and then FL and then always plus L squared. So that's the formula for the sum of two cubes. Notice that everything looks identical. F, L, F squared, FL, L squared. The only difference is that the binomials, if I have the difference of two cubes, then this is a subtraction. If I have the sum of two cubes, then this is a what? Addition. So they differ here, and the only other place they differ is here. Everything else is identical. Now again, you don't have to memorize this. I'll give you this. You just need to know how to use it. So let's go back now to number 3. This is a sum of two cubes. So here's your F and this is your L. So using our formula, what is my binomial?
3 plus.
Right, F plus L, 3 plus 2x. Now my trinomial. Remember, your trinomial, you take F multiplied by itself. So what's F?
9.
But what's F? 3. 3 times 3 is 9. What does that sign become now? You're not using a formula. It's right in front of you. Minus. Come on, use a formula. It's right in front of you. Then I take f and multiply by L. So what's 3 times 2x? 6x. And then plus L times itself. What's 2x times 2x? 4x squared. So there's your answer. Sum of two cubes. All right, let's practice another one. You got to practice with this to be able to use the formulas very well. Guys, there's no reason you need to miss this because I'm giving you the formulas. You have the formulas. Okay, what about this one, number 4? 64x cubed minus 27. 64x cubed minus 27. What's the GCF? What's the GCF? 1. GCF is 1. How many terms do you see? 2. What sign's in the middle? Subtraction. What do you think it is? The difference of 2 squares or 2 cubes? 2 cubes. Because I can write 64x cubed as what times itself 3 times? 4 times 4 times 4 is 64. So 4 what? X. I can write 27 as what cube? 3. So there's my F, there's my L. And all you do is use your formula. So what's the answer? What's my binomial?
4x minus 3.
Very good. All of you should be able to get that part. 4x minus 3. Now the trinomial. Now here's how we deal with the trinomial. Remember, my trinomial, the formula is F minus L times F squared plus FL plus L squared. That's the formula for the difference of 2 cubes. Notice in my trinomial, the first thing I see is F squared. So if you need to, write out F squared because that's what I'm trying to find. F squared means F times F, right? What's F in this case? 4x. So what's 4x times 4x? 16x squared. So that goes here. So F squared, 16x squared. Plus, and then I take F and multiply by L. What's F in this case? 4x. What's L in this case? 3. What do I get when I multiply that out? 12x. Plus, and then I take L and I square it. Next one is L squared. What's L? 3. So 3 times 3 is 9. And that's all you do. There's your answer. It helps if you write it like this for some of you. Some of you can do it in your head. Some of you may need to write this out. You may need to write it out. Number 5. What about this one? Let's think about this one. You have 54x cubed minus 2. 54x cubed minus 2. GCF is 2. Very good. GCF is 2. 2 times what? 27 x cubed minus 1. All right, am I done? Is that the answer? Why not? Because that binomial, 27 x cubed minus 1, is the difference of 2 cubes. What times itself 3 times is 27x cubed? 3x. What times itself 3 times is 1? 1. So there's your F, there's your L. Now, let's go ahead and factor this now. All right, so I'm going to go ahead and write the answer. Don't forget your GCF, so what must I write as the answer? 2 times the binomial. What's my binomial? Times the trinomial. What's F squared? 9x squared, good. Plus F times L plus 3x plus L squared. 1 times 1 is 1. There's your answer. You're done. That's all you do. Okay. All right, let's do one more, and then we'll see what we can do. Let's try one more. Let's do a sum of two cubes. So let's look at this. Number 6. Let's look at 125x cubed plus 216y cubed. Now don't let that throw you off. What's your GCF? That's 125x cubed plus 216y cubed. 1. How many terms do you see? 2. What sign's in the middle? Addition. So is this the sum of two squares? No. Is it the sum of two cubes? Yes. Because I can write this as what times itself 3 times is 125x cubed. 5x. Because 5 times 5 times 5 is 125. All right, now 216. Think about it. Use your calculator if you're not sure. So let's say you think, okay, what number times itself is 216? So in your calculator, you're thinking, okay, let me try 4. So you say 4 times 4 times 4. That's not 216, right? So then you say, well, let's try 5. Well, 5 times 5 times 5 is not 216. So then you're going to say, let's try what? 6. So you're going to say 6 times 6 times 6. And I messed up. So that does give you what? 216. So that'll be 6 what? Y. Use your calculator to help you. So is this the sum of two cubes? Yeah. What's F? What's L? All right, so now I know my binomial. What's my binomial? 5x plus 6y. All right, let's talk about the trinomial now. So remember, we're factoring the sum of two cubes now. So it's f plus L times f squared, then what else? Minus, use your formula, it's in front of you. Minus what? FL, and then plus L squared. Okay. F squared means F times F. What's F in this case? 5x. What's 5x times 5x? 25x squared. So there's my first. Minus. Okay, now let's talk about FL. FL means F times L. F in this case is 5x. L in this case is 6y. What do you get? 30xy. Plus L squared. L times L. What's L in this case? 6y. What's 6y times 6y? And there's your answer. You're done. That's all this is. It's not difficult, just using a formula. Okay? All right, so let me give you this. So this is part A. Now part A, I'm going to go ahead and cover this real quickly now. Part A is the difference of two squares. So use our examples to do that. Now, I want this number 10, when you do number 10, oh, and remember there is one that's the sum of two squares. One of these is the sum of two squares. And you can obviously tell which one it is. Which one? 9. Because all the others are differences, right? The sum of two squares cannot be factored, so what would you put here? Prime. With number 10, when you factor this, I'm letting you know now, when you factor this as two binomials, one of those binomials can be factored further. So it'll be 3 binomials that you'll end up with. So just see what you can do with that one. Try and work on this before next class period. It's not due a week from today, but I want to see what you can do with number 10. Number 10. All right, so that's that one. Then this is the sum and difference of two cubes. sum and difference of two cubes. All right, so those are the two. All right, so I'm going to put this right here. All right, when you leave, those the two. Now remember, at the beginning of class, some of you walked in late. Beginning of class, I gave out two other worksheets. There's one of them. No, those are the same. There's a practice 1 and a practice 2. Here's practice 1.
And what's due today?
A, B, and C 13.3.
Oh, that's not mine.